Morning, students. It's June. Today is June the 28th. This is Math 2008. Our plan is to work on 2.3. We will be talking about continue our discussion on sets, and we'll introduce two or three terms today. And we will also do some problems from your math lab, and the book has the same problems, so we'll see. So first we will talk about intersection, okay? We use an upside down U to denote it. A intersection B. Suppose A and B are two sets. And let's take an example. Of course, you can read the little box above, but let's take an example. I'll give you a couple of examples, okay? So suppose we have two sets, A and B. A has the four elements, 1, 2, 3, and 4. The order doesn't matter. I took them in order just for fun so that we can keep track of the elements. And B has these three elements, 3, 4, and 5. The intersection of A and B is another set. What kind of set is that? Well, that's a set that contains elements of both A and B. Okay, that's going to be only 3 and 4. Okay, so the English word and is associated with intersection. If something is in the intersection of two or more sets, it must belong to all the sets under consideration. It must belong to set A and it must belong to set B. And if we have more sets involved, it must belong to all those other sets. Okay, intersection B is 3 and 4 because 3 and 4 belong to both sets. Intersection is just another set. Okay, let me give you one more example. So let's say here I have 7, 8, and 9. So now I have two sets, A and B. Okay, what is the intersection of A and B? There is nothing in common. Nothing belongs to both A and B. So my set is going to be the empty set. I can write it like that. Sure, totally fine. There's nothing that belongs to both sets. Or we can write it as follows. I'm looking for phi, you can tell. So that's what we mean by intersection. Okay. We have two more definitions in this in this section. Not too bad, I think. The next one is union. So what's union? Union is when you take the elements of set A and the elements of set B and you put them in the same file. Okay, nothing gets repeated. Okay. So let me take another example here. 4, 8, and 9 is fine. And union is denoted by a symbol that looks like the letter U. Probably it does come from that word. So A union B is all the elements of set A, and then you put all the elements of set B. Now, watch, I didn't put 4 twice. You don't put anything twice in a set. So 4 appears only once, even though it belongs to both sets A and B. What's A union B? Grab all the elements from set A and grab all the elements from set B, put them in the same pile. This is conceptual meaning. The formal definition is if something belongs to A union B, then it belongs to either A or B. The word or is associated with union, the word or. So let's write it down. The word or is associated with union. And the word and is associated with intersection. Okay, you want to keep that straight. Let's draw a picture for these two. All right, guys? What does it mean? Let me see if I can find a picture. Let's take this. Okay. A union B, let's say, when we draw two sets, we generally assume they overlap. If they don't overlap, there's nothing there. Let's say this set is A, the circle, and this set is B. So A union B would be, let me write it down. A union B will be all of A and all of B together. This is the representation of A union B. Okay? Everything in A, everything in B. So in order for something to be in A union B, you might be wondering, why am I saying the word or is associated with union? Well, this is why. If something belongs to A union B, it either belongs to A or it belongs to B. Now in English, when we say or, we mean either this or that or both. Get that straight. Let's do one more. Let's do an intersection description. What intersection B? Intersection B is the overlap. Okay, the part that belongs to both A and B. So it'll be just this football shape. Okay, all right. The next definition is a little tricky. People find it a little difficult. Okay, it's A minus B or B minus A, and they're not equal. Okay, now we don't read it A minus B or B minus A. Now you can say it, most people will understand you, but here's the rub. It's read or it's this is called the complement of B with regard to A. And this is called the complement of A with regard to B. Let's focus on one of them. It's called relative complement. What does that mean? Okay. So I'm going to show you the whole thing conceptually first, okay, so that you understand what it means. And then we'll do some problems and hopefully things will make a bit more sense. Let's do the defining both A minus B, B. Well, let's stick to B minus A. Okay, let's just stick to B minus A for now. That's what they're doing here. We're going to just stick to that. Okay. B minus A would mean, conceptually, from the set B, get rid of the part that belongs to A. So you're left with this little crescent. I call it the crescent. The middle part is the football. Okay. This crescent is B minus A. So if something is in B minus A, it's in B but not in A. So what's A minus B? Now we are ready to handle A minus B, I think. A minus B is the same thing, or it's red, complement of B with regard to A. I'm going to use pink. A minus B is this. From A, get rid of anything, any part of A that belongs to B, remove it. So the pink one is this. With me, guys? So again, it's called relative complement. We can say B minus A, but the proper way of saying is complement of A with regard to B. We can say A minus B, but the proper way of saying is complement of B with regard to A. And they're not the same. They're two different sets. All right, wonderful. Now, we will use three sets. So let's look at a Venn diagram that involves three sets. We will not use anything with four sets. We just won't. All right, so I have three sets, A, B, and C. Okay, what's A union B? How do we shade it? A union B union C, I'm sorry, A union B union C is going to be, if something is in A union B union C, it's either in A or in B or in C. That really is another way of saying everything in the three sets all put together, nothing shaded twice, or planted twice. Okay, this is the representation of A union B. Okay, how do you represent A intersection B intersection C? Well, we delete this. That was for A union B union C. A intersection B intersection C, recall, must belong to A and B and C. That's the only part. That's the only part that belongs to all three sets. Okay, this little triangle. Informally, I call this the triangle. Okay, that's A union A intersection B intersection C. Let's do one more. How do we shade complements here? How do we shade complements? Let's remember, guys, from last class, complement of C, set C. Let's find complement of A. I'm going to write it like this. Your book puts a bar. What's A complement? Anything in the universe, this rectangle represents the universe, everything we are talking about. Anything in the universe that doesn't belong to A. So it's going to be like this. Everything outside circle A, ignore B and C as if they don't exist. Okay? That's A complement. So let's do one more that's a little more challenging. What's A union B and the complement of that? Well, first, first, we have to find A union B. I'm going to use two pictures here, okay? I'll do it carefully, step by step, in two stages. Okay. First, I'm going to find A union B. I'm going to ignore the complement. Clearly, A union B, I don't have any reference to C. The small c stands for complement, has nothing to do with set C. So A union B is going to be all of A, all of B put together as if they together form a set. Now, my real question asks me to find the complement of A union B. All right. A union B complement would be everything outside the pink shaded region that's inside the rectangle. And that's going to be, my final answer is going to be in green. So are we clear, guys? How we do it? I'll do one more for you. So my answer is the green shading. Okay. I'll do one more for you. Then we're going to look at some of the word problems. So how about this, guys? How about this? A intersection B intersection C and complement of that. Right. I'm going to do it in two stages. I'm going to first find A intersection B intersection C, which is this little triangle, so to speak. Okay. But I want complement. Now, my answer is going to be in pink. This is going to be my answer. It's going to be everything in the rectangle except for that triangle. With me? Wonderful. So you will see in MATLAB, they will ask you to shade things or identify the correct one. And some of them are hard. Ask me to do some of them. They're a lot of fun. Try them. Let me go ahead and I copy pasted two problems from your assignment, word problems, and I'm going to do them. That's the plan. All right. So guys, this is going to be a little challenging. Okay. Let me see. We warn you, but we'll survive. I'm just going to do this. That's a far better choice. All right. Now, I do need the set pictures. All right. So what's going on here, guys? We have a school, Paxton High. 8 played basketball. So we have 3 sports. Basketball, 9 played volleyball, volleyball, and 10 played soccer. Okay. These problems are a little challenging. Okay. This is the height of challenge that we'll encounter in this class here. Okay. Soccer, not 10. Okay. What does that mean? This B circle represents all the people who played basketball. Now, some of these people here only played basketball. These people here played volleyball and basketball, but they didn't play soccer. These people here played basketball and soccer, but they didn't play volleyball. Same thing here. They only played soccer. They only played volleyball. These people here played soccer and volleyball, but not basketball. And these people right in the center played all 3 sports. Generally, when we have a problem like this, we start with the center. Um, Soccer, 1 played basketball, only, and 2 played. So the word only is very important when you're doing these problems. 2 played volleyball, basketball, and soccer. So you want to start with the center and start with 2. Get 2 played all 3 sports. Whenever you see the word only, pay attention. I'll tell you why. Okay, so I took care of that. And it's a good idea to underline it. That way you know you have addressed it. Okay. 1 played basketball and volleyball only. Basketball, volleyball, 1. 1 played basketball, volleyball only. Okay, guys, be careful here. If they say 1 played basketball and volleyball only, that means they played basketball and volleyball, but they didn't play soccer. Now, by looking at this picture, I can say 3 played basketball and volleyball. Of course, 2 of them played soccer as well. So again, let's underline. All right. 2 played volleyball and soccer only. Volley and soccer. 2 played volleyball and soccer only. I'm going to put 2 here. Again, the word only is a very important word. 2 played. All right. 1 played basketball and soccer only. 1 played basketball and soccer only. Put 1 here. All right. Now you go back. I don't even have to underline. The rest of the statements are obvious and they're on the top. All right. So guys, if 10 played soccer, they didn't say 10 played soccer only. Some of these soccer players may have played the 1 or the 2 other sports, and they sure did. If 10 played soccer only, the soccer circle should add up to 10. We have already accounted for 5 people. I have 5 more people left. So I'm going to put 5 here. And check. 5 plus 2 plus 1 is 10. 9 played volleyball only, 9. So what do you need to put here for the volleyball circle to be 9? I would say 4, because 4 plus 2 plus 2 plus 1 is 9. 8 played basketball. So what do you need to put here? I would say 4. Okay. Let's read the question of eighth grade setbacks and I. Eight played basketball, nine played volleyball. How many played one or more of the three sports? By the way, guys, there could be, of course, there are people in the school who didn't play anything, any of the three sports, right? They would belong outside the three circles. Now, the question doesn't talk about these people, which is fine. So they're saying how many played one or more of the three sports? 4, 5, 9, 10, 11, 12, 13, 14, 15. 14 plus 5 is 19. The answer is 19. Again, when you're doing sets, you have to be very careful about the word only. I can say by looking at this picture, 4 played only basketball, 4 played only volleyball, 5 played only soccer. But 5 plus 1 plus 2 plus 1 is 10 played soccer. 4 plus 2 plus 2 plus 1 is 9. 9 played volleyball. And 4 plus 1 plus 2 plus 1, which is 8. 8 played basketball. You really have to be very careful about those words and wording. So that's the answer to one of the problems in your book, one of the harder ones. Let's do one more. This is also from your MATLAB. So interesting. We're talking about a two-set Venn. A two-set Venn involves a Venn diagram with only two sets. And we're talking about a fraternity group, 31 fraternity members. They take math or mathematics and art history. Mathematics take both. Okay. So we're talking about math and art history. So I'm going to write it like this. The left circle represents math. The one on the right represents art history. I'm going to write RH for art history. Okay. Now, clearly there are overlaps. Would be overlaps, right? A fraternity with 31 members. Okay, there are 31 people altogether. 18 take mathematics. The math circle should add up to 18. This point and this point should add up to 18. I'm not going to mess with it yet. 5 take both math and art history. So this clearly is 5. This is 5. Okay. Now I can say this has to be 13. The math circle should add up to 18. If this football is 5, this has to be 13. 8 take neither mathematics nor history. So 8 goes outside the two circles. These are the people who take neither of the two subjects. They're saying how many take art history but not math? Art history but not math would go here. Now, when you have a Venn diagram with two circles, you have 4 disjoint regions. This is neither of the two. This is one of the two. This is the other of the two. This is both. So out of these 4 places, you know 3 of them. The values of 3 of them, you don't know the value of the 4th. Let's call it X. Let's call it X. Remember, guys, the question says there are 31 fraternity members, right? So all these 4 numbers better add up to 31. All these 4 numbers better add up to 31. So we can do a little bit of math. We're going to say 13 plus 5 plus 8 plus X is equal to 31. All right. Now, that's 31, 8, 26, if I'm not mistaken. This is 26. And X is 31 minus 26, which is 5. That's my answer. 5 members take art history, but not math or only art history. So guys, that's all I have for today. Okay, we've done a lot of work. These concepts are difficult, and you really want to do some problems from MATLAB. Okay, these two problems, the last two that I did, are from MATLAB. They are considered some of the harder ones, of course. And there's lots of problems that involve shading. I've done some of those. If you run into something difficult, please let me know. I'll be happy to help you. Right? Give me the problem number, give me the screen capture, and all those things. Thank you.